Hello everyone, my name is Mark Rakesh Krishan and I'm gonna give presentation on the topic machine learning for natural language processing. Now introduction to natural language processing and machine learning. Natural language processing, its short form NLP and machine learning. ML are pivotal in artificial intelligence, enabling machines to understand, interpret and generate human language. These technologies, they form the backbone of applications like virtual assistants, chatbots, and automated translation tools. NLP, it is a field of AI that focuses on interaction between computers and humans through language machine learning, a subset of AI that allows systems to learn from data without explicit programming. An intersection of them, ML powers natural language processing by improving language models through training on large datasets. A few examples of those applications are for speech recognition. One is Siri, that is from Apple, Alexa, that is from Amazon, and well, Google Assistant, it is from Google. Uh, some of the examples for machine translation are Google Translate and DeepL. There are also chatbots and conversational AI like ChatGPT and IBM Watson. These are the examples that integrates natural language processing with machine learning. Now, importance of machine learning in NLP. Machine learning techniques are very crucial for advancing in NLP and enabling the processing and analysis of massive text datasets. Machine learning allows models to improve performance over time based on data exposure, like what kind of data it is being feeded into the system. Why ML for NLP? Because it automates the language understanding. It also enhances the accuracy of predictions and responses. Like if you are typing something and sometimes you see a blur or light shade of the next text, then it is the AI that is predicting what you are writing next. It also reduces the need for manual coded rules. Some of the examples of ML techniques are supervised learning. It is used in sentiment analysis and spam detection. Unsupervised learning, uh, it is used in topic modeling and clustering. And there is also deep learning, which is used in complex tasks like text generation and translation. One of the key benefits is that machine learning enables NLP models to continuously learn and adapt, making them more effective over time. There are also quite few challenges in ML for NLP. Uh, Data limitations is one of the biggest challenge in applying ML to NLP. That is availability and quality of the data, because there are some issues with the data like the quality. Noisy and incorrectly labeled data can degrade model performance. Also the quantity of the data. If there are very small data sets, it can lead to overfitting where the model performs well on training but poorly on new data. And bias. If the training data is biased, the model may reinforce stereotypes response. One of the example is like many AI systems struggle with underrepresented languages or dialects due to lack of training data. The solution for it is like data augmentation techniques to increase the dataset size, synthetic data generation, crowdsourced label for diverse data collection. That is why many of the online services and also call services, they ask you for your feedback so that way they can train their AI models. There is also the challenge of language diversity. Developing NLP models for different languages presents unique challenges. Like there are multiple languages in this world. So dialect variations, regional differences in expressions can make language processing difficult. There are also challenge of resource availability. Many languages lack extensive data set, grammar and syntax differences. Some languages follow non-standard syntactical rules, making direct translation very challenging. One of the example is English and Chinese NLP models. They differ significantly due to structural variations in the language. The solution is transfer learning, using multilingual models like MBERT and XLMR, collecting more diverse data set for underrepresented languages. Like if there is a language that very few people speak, then you need to feed more data set into the machine learning model to make it more accurate. There are also references in the research paper to support these points. I have referenced some key research papers that have shaped NLP. For example, Attention is All You Need by Vaswani et al. It introduced the transformer model, which is the backbone of BERT and GPT. Similarly, BERT pre-training of deep bidirectional transformer by Devlin et al. Revolutionized NLP tasks. Also, XLNet, generalized autoregressive pre-training for language understanding. It is a novel approach that outperformed BERT on multiple NLP benchmarks. It is written by Yang et al. Next, I'm going to talk about applications of machine learning in NLP. First is text classification. Text classification is the process of categorizing text into predefined groups. Excuse me. The use cases are spam detection. Like there is spam detection in our email accounts, which filters out unwanted emails. Topic categorization. It classifies news articles like sports, politics, entertainment. One of the great example is that Gmail's spam filter classifies emails as spam or not using NLP techniques. Another application for ML is sentiment analysis. Sentiment analysis determines the emotional tone behind a body of text. Its application are social media monitoring, like analyzing Twitter sentiment about a brand, or a customer feedback analysis. One key example is Amazon uses sentiment analysis to analyze customer reviews and improve recommendation for their product. Another application is named entity recognition, which short form is NER. It identifies and classifies key entities in a text like names, locations, and dates. Its use cases are search engines like Google extracts entities from queries, and legal medical text processing. One of the key example is a legal NLP model identifies contract clauses relevant to different laws. Another application is machine translation. Machine translation enables real-time text conversion between languages. Examples are Google Translate and DeepL Translator. There are quite few challenges like contextual inaccuracies and grammar and syntax mismatches. One of the future improvements can be AI-powered translation incorporating cultural context. Another application is chatbots and virtual assistants. Machine learning powers chatbots and virtual assistants enhancing their ability to understand and respond to their user queries, like customer services, providing instant support and information. Like if, like most of the companies, if you uh, call their customer support, and AI call routine will be there to answer you. That is the most common thing happening right now. Personal assistants, helping users manage tasks and schedules. Some of the key examples are Siri, Alexa, and Google Assistant. There are also challenges in ML, like bias. Bias in machine learning models can lead to unfair or inaccurate outcomes in NLP applications, like discrimination, potentially reinforcing stereotypes. Its solution is implementing fairness aware algorithms and diverse training dataset. One of the example is gender bias in machine translation, like doctor versus nurse, because both of them works in the medical field and they care for the patient. Existing methods in machine learning for NLP, one of them is supervised learning. Supervised learning is a common method in NLP where models are trained on labeled datasets. It supports vector machines used for text classification. It also supports neural network effective for various NLP tasks. Example is spam filters and sentiment analysis model. Another is unsupervised learning. Unsupervised learning techniques are employed in NLP to find patterns in unlabeled data. It is clustering, grouping similar texts without predefined labels, topic modeling, discovering hidden topics in large text corpora. Its example is latent directlet allocation and word-to-vector. Also, there is reinforcement learning. Reinforcement learning plays a role in NLP by allowing models to learn from interaction with their environment, like dialogue systems, improving conversational agents through feedback. Game AI, enhancing language understanding in game context. Its example is OpenAI's GPT, fine-tuned with reinforcement learning. Also, let's talk about the future direction in ML for NLP. Potential advancement in machine learning for NLP includes transformers and BERT, revolutionizing language understanding, multimodal learning, integrating text with other data types like images, models that can generalize to unseen tasks, that is zero-shot learning, and also self-supervised learning, that is reducing dependence on labeled data. Let's discuss about the potential improvements in NLP. It's like encouraging a discussion on possible improvements in NLP through machine learning. We invite input on in innovative algorithms, like what is new method that could enhance NLP, like real world application, how can we better implement NLP on various fields, or ethical AI, how can we make AI models more transparent and fair. That's because I did a conversation with a more trending AI, that is ChatGPT, and I asked these questions to ChatGPT, and it's like there is specific laws given to the ChatGPT that it will be more ethical towards humans, like with a helping nature, rather than developing its own sense of what is ethical. Also, there are reference books. Excuse me. I would recommend this reference books like Speech and Language Processing by Daniel Jurafsky and James H. Martin. Another one is Natural Language Processing with Python by Stephen Bird, Ivan Klein, and Edward Lauper. The third one is Handbook for Natural Language Processing, edited by Nitin Edurkya and Fred J. Demirau. Fourth is Text Mining with R, a Tidy Approach by Julia Silv and David Robinson. The other references that I got online are like archive.org. It is a repository for electronic preprints known as ePrints across various disciplines, including NLP. Researchers frequently upload their latest papers here. Another is ACL Anthology, a digital archive for research papers in computational linguistics and NLP. It is maintained by the Association of Computational Linguistics, that is ACL. It includes conference proceedings and journal articles. Another great one is Papers with Code. This platform tracks the latest advancement in NLP, providing links to research papers, code implementations, and evaluation metrics for various tasks. Conclusion. In summary, machine learning is transforming NLP by enabling powerful applications, but challenges like data limitations, bias, language diversity remains. With continued research and innovation, NLP models will become even more effective. Key takeaways are machine learning enables natural language processing models to handle complex linguistics tasks. Challenges such as data limitations and language diversity requires innovative solutions. The future advancement in deep learning will further enhance NLP capabilities. That's it. Thank you for your time, and I look forward for your questions if you have any. Thank you.